Hello, welcome back everyone. My name is Rabi Isa, and today we are going to solve a certain problem under stress strain diagram. So here we can see from the screen the question said the cast is made of steel that has a specific weight of 80 kN per meter cube. Determine the average compressive stress acting at point A and B. So this is just a question, and the other details are from the diagram. So we have some notice in this question. First, for this, it is some specific weight. When we say specific, there is a kind of properties of the of material that is divided by volume. So for each property of material, that's one volume of that material possesses the property. For instance, this is a weight of one volume. So for us to get the total weight of the material, we need to multiply by the total volume of the material to get the total weight. So that's what we mean by specific property of material. For instance, specific heat capacity and the rest of them. So now for us to solve these problems, we need to find the area, the volume, so as to get the force, that's the weight, and then go straight forward to solve the question. So now let's go and see. So from the diagram, let us redraw the diagram for better understanding. So for instance, supposing this is the cylinder and so now this is the top. So the weight is always acting down, so this is a weight, so let us call it WA, and there must be a force that will oppose this weight to maintain it in equilibrium, so let's call it P. And we have given that the distance from this point to this point is given as 80 millimeter, and also the radius is given as 0.2 from the diagram. So the radius is given as 0. Maybe if it is in terms of meter, or let just take it in millimeter, so 200 millimeter. Okay, so now let us get the specific weight, the weight from the specific weight. So we know that specific weight is always equal to the weight of material all over the volume. So this means that the specific the weight of the material is equal to the specific weight times volume. So how do we get the volume? So we can get the volume from the diagram. So we know it is cylinder, and the volume of cylinder is equal to pi r square h or L. So let's say it pi r square h. So from the diagram, we know R is equal to diameter over 2O is just given from the diagram, which is 200 millimeter. So let me convert it to meter. We have 0.2 meter, and also the height is 0.8 meter, that is 80 millimeter. We convert it to meter. So therefore we can get the volume, which is going to be equal to pi into 0.2 square times the height, which is 0.8. So now the specific weight is equal to, the weight is equal to specific weight, which is equal to 80 times volume, and the volume is pi into 0.2 r square times 0.8. So the weight is equal to 8.042 kilonewton. So now the system is under equilibrium from the diagram I draw. So it is maintained in equilibrium. That means this summation of f of y must be equal to 0 for the system to remain in equilibrium. So for equilibrium, summation of f of y is equal to 0. Taking up as positive and down as negative, so the phi is positive and the weight is negative, which is equal to 0. So this means that the force P is equal to the weight of the body, which is equal to 8.042 kilonewton. Now, for us to get the stress, we need to find the area, which is equal to phi r square. Therefore, and this is equal to phi into 0.2 radius square. Therefore, the stress is equal to the force over area, which is equal to 8.042 over the area, which is equal to phi 0.2 square, and this is equal to 64.0, or we can just leave it like this, kilonewton per meter square. So this is the stress in this cylinder. Alternatively, we can just say the force is equal to the weight, which is equal to the specific weight times the volume, which is obviously area times the height. Okay, so we know the stress is equal to the force over area, and this is equal to specific weight times height, ah, all over area. So this area goes area remain, specific weight times the height. So generally, if this kind of problem is arise, we can just say the stress is equal to specific weight times the height. I hope this is clear. Thank you very much for watching us. Please do not forget to send us your question whenever you arise with some certain confusion. Thank you very much.